Hi everyone, thanks for joining us today. I'm Wendy Bradley, Digital Brand Manager for OxTS, and I'm here as your moderator today. My role is to support you on any technical issues if you have any during our session, and I'll also collate any questions you'd like to ask our presenter, and I'll put them to him on your behalf during the Q&A session at the end. So if anything occurs to you at any time during the presentation, please type your question into the questions chat box. If you're unfamiliar with the GoToWebinar controls and you don't see your questions panel anywhere on your screen, it might be that your control panel is closed currently. If that's the case, you can look for a small orange arrow floating somewhere on your screen, and you can click that to toggle your panel open so that you can type your questions, and closed again so that you can maximize your viewing space. Your presenter today is Jonathan Deacon, OxTS Product Engineer. He'll be expertly taking you through this webinar, explaining how you can shorten the time to survey, including tips on configuring your INS to ensure a productive survey workflow, methods of efficient data collection, and speeding up INS and LiDAR calibration. We are recording this session today, and we'll email the link to all attendees after the session so that you can review it again at any time you wish after today's live event. You can also share the link with colleagues who couldn't be here today. That covers all of the housekeeping points, so please join me in welcoming your presenter. Over to you, Jonathan.
Thank you very much, Wendy, and welcome everybody to the webinar today. So in this session, we're kind of hoping to cover three main points. So how can we configure our INS to reduce the time to warm up and decrease the time to getting good data? What methods of data collection do we have? So that'll include RD file streaming and recording real-time encom, and then methods of processing. And all of these things are an attempt to speed up our survey workflow. So if we start off on configuring our INS, and to do this, we kind of really want to appreciate why we warm up in the first place. And there are kind of four key reasons why we do it. So firstly is IMU temperature. So within the IMU, we have accelerometers and gyroscopes, and the output of those depends on the temperature that they are. So if your IMU is cold, it will produce a different output to when it is warm. So we want to heat the INS up so it's at an operating temperature and stable. Next is our accelerometer and gyroscope biases, and these are estimated by our Kalman filter, so our navigation engine, and again, they vary between accelerometers and gyroscopes what the output is depending on what the biases are. And then the final two are refining INS orientation and antenna lever arms. So again, when we configure our INS in navconfig, we give you a range of values between which we ask you to measure these, and accuracy to measure these within. So how can we refine that and reduce the time the Kalman filter takes to come to a solution? It's worth saying that the Kalman filter is a data-driven algorithm, and we need data at the start of from initialization to produce good quality data for surveying. So how can we reduce these to reduce time to inspect performance from one of our INSs? So firstly, IMU temperature. Our newest, smallest, lightest INS, our XNAV 650, is a temperature calibrated INS. This means that the gyroscopes and accelerometers have been calibrated over a wide range of temperatures so that we know what the outputs will be at each temperature. And that's for a range of -40 to +70 degrees Celsius. Our Survey Plus is not a temperature calibrated INS, but features a more stable, temperature stable IMU. This means that the output varies less over that range of temperatures, so from -40 to +70. But so the impact is less between different temperatures, but also is not negligible. It's small but not negligible. So if you want good data, I advise to turn it on as soon as possible to allow it to physically heat up. So we know any electrical device, when you turn it on, if you feel the computer that you're watching this on right now I'm sure it will have a slight heat to it. So that's essentially what we're trying to do, just heat it up to a normal working temperature. So sensor biases and scale factors. So the Kalman filter consists of 24 states, and this involves all your position, orientation, velocities, but it also includes measurements of the sensors within the unit. So these change over time. So at calibration during manufacture, we will model the IMU so we can produce values for each of our units for their scale factors and biases in their IMUs. But over time, sensor degradation and potential future misalignment. So if your accelerator moves even 0.1 of a degree in the space of a few years, then this will change the output of the unit. So we recommend sending your INS to OxTS for regular calibration to ensure these values remain as true as possible. And then I've kind of grouped 3 and 4 together. So our INS orientation and lever arm refinement for our antennas. So as I mentioned, when we ask you to configure your INS, we give you a range of values for which it's acceptable to measure these values. So orientation within 5 degrees. So your INS needs to be pointing in the direction you've said within 5 degrees. And then your INS to antenna lever arms. These are especially hard to measure if you're in a car, for instance, and your INS is inside the car and your antenna's on top. Obviously, they can be up to kind of 2 meters away, and to measure these extremely accurately is very difficult. So that's why we give you a wide range of values that we can accept at first. But this does increase the time for the Kalman filter to come to a solution. So the first few minutes of an INS in operation, the Kalman filter is using data and propagating that forwards to find a solution to find an accurate lever arm for where your primary and secondary antennas are placed. But if we have a permanent setup, we can use our improved configuration functionality to hopefully reduce the time that we need to converge to a good solution. So improved configuration has some prerequisites. So to use this, we need to have a dynamic warm-up that must be completed with RTK accuracy or post-processed accuracy. Either real-time or post-process corrections. And the reason for this is if we get rubbish data in, so if you're not using corrections and your data is only accurate to kind of 30, 40 centimeters, then there's no way that we can refine a antenna lever arm to within 1 centimeter. So it's a case of if you have rubbish data going in, you're going to get even worse data coming out. And then again, as I say, we only can kind of recommend this for more permanent setups because there's always a chance that if you remove your INS from either your car or your drone and then put it back on, you're not going to put it back on in possibly the same place or the same orientation exactly. And so as a part of improving your configuration, the accuracies that the navigation engine thinks it has are lowered. So there's a chance of false reporting and inaccurate data. So again, must be using corrections and is more advised to do this for more permanent setups where you know you're not going to change. So how do we use improved configuration in navconfig? So firstly, we do a warm-up with corrections. We then open navconfig and then select improve configuration and follow the steps. And I'll walk you through that now. So as I say, warm up 10 to 15 minutes. We do our classic OxTS figures of 8, circles, and then straight lines for with hard acceleration and braking. And this really gets all axes of the IMU moving. We then open up navconfig. We can select improve configuration, so the bottom option when you open up the application. We have three options for basically finding our configurations. So we can read settings from a folder. So if you have a config saved somewhere on your computer, we can read it from a raw RD file. So your pre-processed navigation data, and then we can read it from a device as well, so a live device. So in this case, I've selected read settings from an RD file. So I've gone out, collected some data, and I'm just taking that raw navigation file and opening it here. And within that lies the configuration. So your source, this is the data that you want to use to improve your configuration. So this is your warm-up file, and that can either be a processed encom of your warm-up, or straight after your warm-up you can read from your device. So you can read a real-time output from your device. In this case, I've chosen a file for this. I then select the settings that I want to improve. So here I've selected my IMU orientation and a secondary antenna position. And we can see that we have a value going in, and then we have an improved value coming out. We see the accuracy improvements, and these will be stored in the configuration. I can then either save the configuration locally to commit to a device in future, or to use to process an RD file, or I can commit to a unit straight away. So that's the configuration section done, and now next we're moving on to methods of data collection. So we have two methods of data collection techniques here that we see people using to purely to speed up their time to producing data at the end. The first is recording encom in real time. So encom is the OxTS file format for process navigation data. So it's not our raw GNSS and IMU data. It's been processed. It's been through the Kalman filter, and it provides position orientation and time. So there are pros and cons of logging your real-time encom. The pro is that obviously you have no processing time needed because you're effectively using the processing power of the box to do this. But then the cons are you get less accurate data than if you were to post-process an RD file. So if you were to post-process an RD file in combined mode, which means you're going forwards and backwards over the data, you're going to get worse data if you're using real-time processing, because you're effectively only going forwards over the data. And you must also always be using corrections if you want centimeter level accuracy in real time. So how do we do this? It's very simple. In your configuration, in the advanced commands section, you simply log, type these commands into the advanced commands section of navconfig. So this log UDP command essentially just says log the output of my Ethernet output, and then the second command essentially just says log this as an encom file format. So our second method is RD file streaming, and this allows us to output raw GNSS and IMU data over Ethernet in the XCOM file format directly to a computer. So instead of having to go into our unit via FTP and pull our RD file off, which if it's a particularly long RD file can take a fair amount of time, or you might not have a skilled operator who doesn't necessarily know how to do this. then RD file streaming could be a solution for you. So what are the pros and cons of streaming your raw GNSS and IMU data? Firstly, it removes the need to access the unit via FTP, as I just mentioned, or navsolve to obtain the file. So we can produce a smoother, more automated processing workflow. And it also allows us to retain the accuracy of post-processing the raw data. So again, if we stream the RD file, we still have to post-process it in navsolve or an equivalent. But what are the cons of it? Well, it requires more time to set up initially. It requires you to have set up a process, set up a workflow, a smooth workflow, and that takes time. And it obviously still requires processing of data. So how do we do it? Firstly, you need a feature code for your unit, the raw out feature code, and you can contact sales to obtain that. But besides that, it's just using advanced commands similar to the ones we saw with the encom, recording live encom. And then this is output in the XCOM stream, which you can log in a program such as Wireshark. And then we need to post-process this file in Blended, which is effectively the back end of navsolve. So to obtain this, you need to sign a non-disclosure agreement because essentially we need to help you through this process. And if you're interested in this, firstly, I'd say this is for those with more established workflows who are looking to increase efficiency and really automate their systems. Excuse me. And then if you want more information, then please contact me, jdeacon@oxts.com. So finally, moving on to data processing. So if we have retrieved our RD file from our unit, how can we speed up our processing? So how can we have the fewest clicks to producing a large amount of data? And the solution to this is batch processing. So if I have a vehicle going out and recording multiple RD files in a day, then I don't want to sit through these processing each one by one. It'd be much easier if I can do it together. And that is the purpose of batch processing. So I'm going to walk you through how to do this in navsolve. So we can see here I have some LiDAR data from Oxford, and I'm just going to post-process these 3 files simultaneously. So firstly, I scroll through the left-hand side. So I've selected my files, and then I'm moving on to processing them. So if I'm using Rhinex data for this, I can retrieve. I can still retrieve Rhinex files from the auto downloader within navsolve, or I can apply my own source externally. I can then select if I want to export any CSV files. So in this case, I have a camera on top of my car and I want to generate an output trigger file. So I want to know where I am when I've taken each picture. And then finally, we have our batch processing page, which has all the information that we have selected above. So I've selected my Rhinex files that I'm using, the 3 source files that I'm using, so the 3 RD files. I've selected a maximum distance of 100 kilometers for my base stations, and I've also added an export file here, just a CSV file with latitude, longitude, and altitude in there. And we can see I've also added my trigger file. And so we can then process these and produce all of our encoms and export files. So if we recap what we've gone through today, firstly, we have gone through configurations, so methods of really reducing that warm-up time and decreasing the time it takes to get to good data. We've looked at doing that through the improved configuration option in nav config. We then moved on to data collection, so RD file streaming, so streaming that raw GNSS and IMU data, and then also looked at logging real-time encom on our units. And then finally, a quick look at batch processing. So processing multiple files with the same configuration at once. So decreasing the amount of clicks it takes for me to produce my final process navigation files. So all it takes to say is thank you very much for listening, and we can move on to any questions that we have now.
Thank you, Jonathan. That was really good. We have had one question in already. John's asked, he said, I've never heard of XCOM. Is it related to NCOM, please?
Okay, so the answer to that is kind of. So XCOM is the combined data format that OxTS outputs. So it has multiple individual streams going in it, and NCOM is one of them. But we can also output things like CAN and obviously that RD data over XCOM as well. So it's a multi-stream combined stream coming out of the Ethernet port on the unit.
Okay, great, thank you. We haven't had any more questions just yet. Just to remind everyone, if you do have a question, please type it into your question box. We have got a few minutes for questions if you do want to ask anything. Still not seeing any more yet. Give everyone just one more minute to quickly type. No, I think that's it for now. As Jonathan said earlier, he did give you his email address, so if you do have follow-up questions, please do feel welcome. Just to mention finally, this is one of many free webinars that the OxTS team run to support our customers, and you can find more of those on the website in the News and Resources Hub. If you would like more information more generally than from Jonathan, you can contact us via the info@oxts.com email address at any time. And also, if you're interested in buying any OxTS INS devices or upgrading your current ones, again, it's the info@oxts.com email address you need to look for, or just use the contact us form on the website. And we'll look forward to seeing you again at the next webinar. So thanks again, Jonathan. That was really great. And we'll see you next time.
Cheers. Thank you all.